So I'm going to try to explain to you what's going on this graphing worksheet so you can use it as extra practice for both analyzing the formulas and doing the linear regressions on your calculator. The emphasis here is going to very much be on if you're using a TI Nspire or an 8384 in order to get this information in correctly so that you can actually get meaningful numbers out of it. So for this particular question, we're talking about launching some sort of a little rocket. I give you the formula, I say v squared equals 2ad, and then I give you some values. Now, one thing that I've done here to be extra nice to you is I said the third column is velocity squared. And I even did the correct thing where I showed these units squared. That all has to be done. The measurement along with its units in rounded brackets, measurement and round brackets. Now, I might not have said this at all. I might have just said, I'm giving you displacement and velocity. I look up at the formula, v squared equals 2ad. Too often people get really focused on just manipulating that formula, solving it for a, and coming up with values for a there. That's not going to work for us. Instead, to do a linear regression, I need to look at, in this case, v, one of the things I was given, is being squared. It's exponential. The d, which I was also given, nothing exponential is happening to it. It's being multiplied by 2a, but that's not exponential. That's how I know that since v is being squared there, I have to come up with another column for v squared there. Now I want to show you how I would get those numbers onto a calculator. So we'll switch for a moment to the view on an Nspire calculator. From your home screen, you do want to create a new document. Now for this, it's way too tempting to say, oh, I'm going to make a graph and stuff. We're not doing that. That's function graphs like you do in math. Instead, we are starting with a spreadsheet. So I look at these columns up top, and that's where I put in what I'm putting on the chart. Just the chart, not a graph yet. So I'm just going to call this D for displacement. And then I'm going to go down here, and in the cells, the individual boxes, I'm going to start putting in my values. 25, 50, 75, 100. I just keep going down, working through the list until I've got all of them. And on the Nspire calculators, if you make a mistake somewhere in here, it's actually much easier to go back and fix things, even if you're further along in the question. The TI-83s and 84s are a lot less forgiving, so just kind of watch out for that. My next column I'm going to call V. It doesn't have to be anything fancy. You don't have to put in the whole word velocity, and don't bother trying to capitalize things or put in units. This is the best you're going to have. 37.4, 53. I got a whole bunch of just crazy looking numbers to type in here. 4, 6, and again, if you make an error, you can always go back and fix these. Now here's the special part. I do need a third column now that's going to be velocity squared. I don't need to individually calculate those. That would be miserable. Instead, I'm just going to name this column, not just v, because it isn't, and I can't put in exponents like the squared power, so I'm just going to type SQ for squared. You can type whatever you want. You could type out the word squared. As long as it's meaningful to you, it makes sense to you that that is v squared. Now I go one box down. You'll see on the screen, this is equals, because the power of a spreadsheet is that it will do calculations for you. All of these cells have the ability, these boxes have the ability to do calculations. I just need to tell it in that box what I want it to do. Now, as a safety, we do have to hit this equals button right here to say, no, really, I'm about to tell you to do something mathematical with this. So over here, I hit equals, and you can see that it becomes v squared equals whatever. I have to tell it. Now, what I really want it to do is take all of these velocity values and square them. I could just type in the v, but especially if I've got a bunch of things I'm keeping track of, I could put in the wrong thing. So I'm going to use the var button right above the number 9. var for variables. It brings up a list. It says, you've already told me along the top here that our variables are d, v, and v squared. Well, I know that I want this to do a calculation of all of my v values being squared. So I can actually hit the x squared button for that, and then hit enter. And it puts in all the numbers for me. This is where it's really nice that if I had made a mistake here and I want to change that to 52, it fixes the v squared for me also. So it will do those fixes on the fly for me. That's how I get the numbers into there. Now, if you're working on a T83 or 84, things are going to look a little bit different because it doesn't have that spreadsheet sort of function. It's still there, sort of, it just looks different. You have to hit the stat button, and that button is just next to where your arrow pad is, so hit stat, and it brings up this. I need to edit my list, so I choose number 1. Now, I was doing some stuff earlier on here, so there's actual numbers. If you ever get to that situation, use the arrows to go around to the top name, hit clear, and hit enter, and it'll clear that for you. So I'm going to go clear and enter. The other thing is, these columns must be L1 and L2 at the beginning. If it starts with like L5 or something, the best thing to do is just do a full reset on your calculator. It'll force the L1 and L2 back. Now, the next part we have to be careful about here is that this way of doing things is not as smart. Previously on the Nspire, I could put whatever I want in whatever column. But here, the L1 column must be my X values, my X axis. L2 must be my Y axis values, has to. And I can't do things to them later. Now, this does mean that I do have to maybe look a little bit ahead, because on the worksheet, you'll notice that in question number 2, I say in the space below, sketch a graph of velocity squared as a function of displacement. Since the name is velocity squared as a function of displacement, that's not just for the heck of it that we called it that. That is naming the axes. Because remember, we always name the y-axis first in the title and then the x-axis. So since it's velocity squared as a function of displacement, displacement is my x-axis. And I must put my displacements here. I must put my velocity squared values there. So as I start putting in my numbers, those will be my displacements. And just by a fluke for this question, oh, I made a mistake there, and we don't want to do mistakes on 83, 84s. I need to make sure in advance that I'm putting these in the right places. Oh, and I did make a mistake there, and I can go back and fix it like that. Okay, and I've got my D's. Now my y-axis has to be the velocities already squared. TI-8384s will let you do some simple stuff here. So 37.4, and then hit the x squared button on your calculator. It will actually put the numbers in correctly. So you have to type them in this way. You can't tell it to do it later, but you can get it to do a simple little bit of math for you like that. So it's not so bad. I just don't like it because I like to be able to put in numbers and then potentially do different things with them on the fly, depending on what kind of problem I'm doing. So there's my X and Y values on a TI-8384. Now you'll notice in number 2, I did give you the graphing space where you could actually draw out the graph if you wanted to. If you forgot how to do all this stuff on the calculator, you could still follow all the rules of doing the graph here. Or, and remember this is or, I do it all on my calculator, and I want to get the slope and y-intercept values. We do this or we do this. Including on quizzes and exams, I always do it this way. You can do it old-fashioned way if you want, or do it on your calculator, and by showing me here the unrounded values for the slope and the y-intercept, I'll know that you did it correct on your calculator. Now that does mean that I need those values on the calculator. So on an Nspire, hit the control button, and you'll see this dock button says plus page. Click on that one, and it says, hey, I'm going to give you something. Now again, we're not choosing graphs. We're choosing data and statistics because we want to statistically analyze what we've got. Your dots will be in different spots. That's okay, because we haven't told it yet what any of those numbers mean. So what I've got to do is go over here to the side. And remember, we were told in the question, velocity squared is a function of displacement. So for the y-axis, I choose v squared. Everything kind of moves around. I choose the x-axis as displacement, and I get my linear regression. Pretty much. It doesn't have the line yet, but I'm close. I've got all those dots. I want to get the values for slope and y-intercept. I hit the menu button. It brings up these choices. I go to analyze, and if you ever choose the wrong thing and you find yourself going deeper and deeper and deeper, remember you can always hit the escape button to jump back a menu in there. But I'm going to choose analyze a regression, and the very, very top one, a linear regression in the format of mx plus b, because a straight line is y equals mx plus b. Choose that one, and you'll see it gives us a function here. Y equals mx plus b. This is my slope. This is my y-intercept. Those would be the numbers that I would record. Those are the numbers that I'm going to use. On the TI-8384s, things will look a little bit different. We're not going to see a beautiful graph to make sure that we did things right, but we can hit the stat button, and this time we want to choose a calculation. Now this is where you have to remember, these calculators were made originally in 1996, and back then they decided to say that for linear regressions, the formula was in the format of ax plus b. They didn't use an m here, but that is still actually the slope. So I know it looks weird, and in math now, ax plus b means something different. But choose number 4, and you'll see something like this pop up on your screen. Depends on exactly your calculator and stuff, but it gives a few options. All you want to do is hit enter, 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 enter a few times until you get to calculate. You can expect your calculator to kind of burp for a second there as it does its calculations. Here's your slope, here's your y-intercept. Again, the numbers that you would record off to the side of the graphing area so that I've got actual numbers that I can say, yep, that person must have done their graphing stuff right, okay? Now it says describe the type of graph you obtained. Nothing fancy here. It's a linear graph. That's all you're telling me. It's a linear relationship. Determine the slope of your graph. Be sure to include units, yada, yada, yada. Don't worry about that because it says if you already did it on your calculator, simply record your rounded answer. Now for the SIGDIGs, I go all the way back up here to the beginning and I look at all the numbers that were used because they're all part of my significant digits. And I look at this, these first 3 numbers only have 2 SIGDIGs. So that means my slope, when I'm actually going to round off, should probably be a 2 SIGDIG number. So back over here, I would record the slope as 55. Now that's a rounded number, and I won't use my rounded number in calculator because I always use unrounded numbers, but it is worth knowing that it's there. The next question says, explain the significance of the slope. Well, slopes are always y over x. And for this particular graph, my y-axis is v squared and my x-axis is d. My slope is v squared over d. That's what it really means. I also have this formula though, and I ask myself, can I manipulate it, change it around so that this is the same as this? Yep, I can. Divide by D, divide by D. So D divided by D is 1. I get this. Now the part that's important is this is V squared over D and so is this. That means they really are equal to each other. That means that even way back here, when I said that that was slope, and way over here when I said that's 2a, they are also equal to each other. Slope equals 2a. That's what I have to get to. In this part, what does the slope mean? How does it relate to the formula? This is what I need. The slope as it relates back to the formula, showing that because two parts are the same, I can jam something together. That gets me to the last question where it says, use your slope. It doesn't say jam numbers into the original formula way back at the beginning. Use your slope to calculate the acceleration. Well, if I want to really solve this, divide by 2, you're going to get that the acceleration is equal to the slope divided by 2. Now on Nspires, there's a very easy way to get that part of the calculation done with completely original, unrounded numbers, so you don't have to worry about any of that stuff. You don't have to worry that you rounded off the numbers and it screws up your answer. So what I would do is Control and the plus page button again. This time add a calculator page. Now remember, what I really want to do is take the slope that I have calculated and multiply it by 2. So I'm just going to say 2 times. Now remember, there was that var button, variables. Not only is that stuff back from my spreadsheet now, it's also new stuff that I've created. So when I hit it, you get a ton of stuff. Most of this we ignore, because a lot of this is actually from deep statistical sort of analysis. But do you see this one that's called stat M? The statistically calculated M, slope value, okay? So I choose that, and it's looking back at the previous pages and saying, I know what that number is. So when I hit enter, I get that. Now remember, really at the end, I should be rounding off for sig digs. Oh, sorry, I shouldn't have said multiply by 2, I should have said divide by 2. Sorry about that. var stat m divided by 2. Wink, there we go, 27. That's a better acceleration. I should be rounding this off to 2 sig digs because my slope is really only 2 sig digs because of the numbers that were originally given to me on the chart. So the best answer from this, rounded off, will be 28 meters per second squared. On the TI-83 and 84s, you really just have to write down that number from the calculator screen and then just start doing your calculations. You'll just type it out without any rounding on your calculator, divide by 2, and get your answer. So yeah, we're ignoring all of this stuff that I just said by mistake. But this way, what we've done is use the slope to do the best possible calculation of the value for the acceleration.